Hello. Okay, so hopefully this is recording. Let me check. I think it is. Um, so I'm going to go through the notes on 4.2, the Isosceles triangle theorem, or as I finally call it, ITT, Isosceles triangle theorem. And we know that an isosceles triangle is a type of triangle with two or more congruent sides. So remember, an equilateral triangle is a type of isosceles triangle. And we have some vocab to go with it. So an isosceles triangle has a base. And it's not that the base is always on the bottom. We call the base the side that's not the leg. So the legs are going to be the ones that are congruent. So these are the legs. And so I could draw it sideways, and the base would be here. So don't confuse like base with on the bottom. It could be different. So then the base angles connect the base and the legs. So these are the angles where the base makes up one of the rays of the angle. And then that one that's left, this is called the vertex angle. So the vertex angle will always be between the two legs on an isosceles triangle. And the thing that's interesting about isosceles triangles and the theorem, the reason why we're all here, if a triangle is isosceles, then what's going to be true is that the base angles will be congruent. The base angles are congruent. They're going to be the same measure, no matter what. And then the converse is also true for this theorem, that if the base angles are congruent, then the triangle is isosceles. So if we were to ever show that two angles in a triangle are congruent, then we could say the triangle is isosceles. That's a conclusion we could make. Now, when it says if these theorems are true for isosceles triangles, then what types of triangles might they also be true for? This would be for equilateral triangles. Because remember, those are types of isosceles. So here's an example. Find the measure of the following. So angle B is this angle. This is a leg, and this is a leg. I know that because those are the ones that are congruent. So this is your vertex angle right here. So my base angles are here. You can almost think of them as opposite the legs, right? This angle opens up to this leg, and this angle opens up to this other leg. And so the angles across from the congruent legs are going to be your congruent angles. So if the measure of angle A is 25, the measure of angle B will also be 25. And my justification would be because of the isosceles triangle theorem. Now, the measure of angle C, the vertex angle, I can use triangle sum theorem because I have two of the angles, the 50 degrees. So I can do 180 minus 50 and get that this is 130 degrees. So the measure of angle C is 130 degrees. And my justification there, I know it didn't ask for it, but might as well show you in case I did. Oh wait, it does ask you, which theorems did you use for this problem? I used isosceles triangle theorem for the first one, and then triangle sum theorem for the second one. Let's make that into a smiley face. Oh, it's kind of creepy. All right, let's look at the next example. So that was kind of a very basic one. Example 2, find the values of x and y. State the theorems that you use. So let's see. Here's my isosceles triangle theorem, and here's the legs. So I know that in an isosceles triangle, the base angles are congruent. So whatever these two angles are, I know they're going to be congruent. I could even mark this as x if I wanted to. Now, right now, the only piece of information I have is this 40. And I might not know right away, but I'm going to do linear pair postulate to say that this is 140 degrees. So I use LPP, linear pair postulate. And you're going to get this problem a lot where you have the vertex angle and you need the two base angles. But because they're congruent, we can figure this out because we know that between them, because of triangle sum theorem, between them, they need to sum to 40 degrees. So 2 of them need to be 40 degrees. So I know if I split it evenly between it, those 2 values are going to be 20 degrees. So I know that this is 20 and this is 20. And so that was triangle sum theorem. And Isosceles triangle theorem, ITT, to do that. ITT. So I was using the fact that all 3 would add to 180, and I knew those would be congruent because it's an isosceles triangle. Now the last one, we don't know. Oh, we could figure out what this is, because if this is 20, the rest is 90, so this is 70. So I can do 180 minus 70 minus 40 and get that y is also 70. Oh, so this is ending up to be an isosceles triangle too. So that was just triangle sum theorem. So x is 20 and y is 70. Now the other way you could have done this, how you could have found y, this is actually a very helpful hint for all these like puzzles, is instead of thinking of them as 2 separate triangles, I could have thought of them as one triangle where the angles are 20, 90, and then I could find y. And if I do 180 minus 90 minus 20, I'll get 70 also. So that's another way you could have attacked it. In example 3, we'll have some algebra. So setting up equations. So here I have a triangle where the base angles are congruent. And if you go back and reread the converse of the isosceles triangle theorem, it states, if the base angles are congruent, then it is isosceles. So because I see base angles are congruent, and whenever you see 2 angles congruent, you can look at the sides across from it and label them as congruent. And I could have put 1 slash mark. I don't know, I have this like thing with 2 slash marks. I like it better. Hey, Robbie. So what are we doing? Oh yeah. We need to find the value of x. Well, I just concluded because of ITT converse that these 2 sides are the same. So I can set up an equation that 2x plus 20 has to be equal to 10x minus 4. And I can solve. I can get 8x equals 24, and x is equal to 3. Now, if I needed to justify it, it would be isosceles triangle theorem converse. And it is important that you know when you're using the converse versus just the regular. So the converse is when your given base angles are congruent and you conclude that it's an isosceles triangle, that you conclude that those 2 sides are equal to each other. So that's why this is using the converse. And then it says to find the perimeter. So this is 26 inches, right? I just substitute in the value of x. And this is 30 minus 4 is 20. Oh yeah, it has to be the same, of course, 26. So 70 plus 52, 122 inches. Please let me have done that addition right. I wouldn't want that set in stone forever. And let's also hope I was recording this entire time. Oh, good, I was. Yay, okay. So, yeah, that's the end. Isosceles triangle theorem. Bye.